Hello friends, welcome back to my channel Real World DevOps. In today's video, we will learn the different types of gateways present in the AWS like Internet Gateway, NAT Gateway, Virtual Private Gateway, Transit Gateway, and so on. But before going to the gateways, we need to understand the VPC architecture and the components of the AWS. Let's assume we have a city, and in that city, we have neighborhoods. Okay, we have the colonies. In colonies, somewhere we have the houses and somewhere we have the banks vault. Okay, let's consider where our houses are present, we can consider as a public neighborhood, and where the bank vaults are present, where the bank location is, we can consider as a private neighborhood. So assume a city as a VPC. Okay, VPC is a logical isolated virtual network in AWS. Okay, where you can launch and manage your resources with full control over IP address routing and security. Next, we have the Internet Gateway. You can consider is as a city gate. Like, um, you know, we have the uh, when we go from one city to another city, we have the toll system. Okay, where vehicles give the toll fees. So this is considered like that. With this a toll, a restriction. So with this city gate, anyone vehicles with proper access can come inside this city, and the resources or the vehicles present in the city can go outside the internet or to the other cities. Okay, now let's consider this public neighborhood. Public neighborhood we can consider as a public subnet. Okay, a public subnet is a subnet whose route table contains a route to an internet gateway, allowing resources with public IP addresses to communicate with the internet. So, in this, we have a private neighborhood. Private neighborhood can be considered as a private subnet, a subnet that doesn't not have a direct route to an internet gateway, preventing resources from being directly accessible from the internet. Okay, so let's come to the route tables. Route tables can be considered as road signs, like vehicles use the road signs, okay, so that they can road signs gives us the direction where to go. Okay, so similarly, in the networking of the AWS, route table is a set of routing rules that determines where network traffic from a subnet or gateway should be directed. And if you know, like in the colonies, we have um, the local gates also. In different colonies, we have the local gates. So those gates you can consider as a checkpost, and checkpost you can consider as a NACL. Means the each subnet has a NACL attached. That is network access control list, which is the security level applied to the subnet level. Okay, so this is a stateless firewall at the subnet level that controls inbound and outbound traffic using allow and deny rules. Next, let's come to the security guards which are present in our outside our house, outside our buildings, outside the bank vaults. If we talk about the private neighborhood, so these security guards, what they will do, they will allow only specific persons to enter into the house or to enter into the bank vaults. Okay, so a stateful firewall. So security group is kind of a stateful firewall at the resource level that controls inbound and outbound traffic for AWS resources such as EC2 instances using allow rules only. First is Internet Gateway. It allows resources in a VPC to communicate directly with the internet. You can consider this as a city's main public highway exit. Anyone can drive out to the world and visitors can come in if permitted. So, EC2 instance with the internet gateway can go to the internet and download the packages. Okay, let's see some important use cases of the internet gateway and some important points. Internet gateway makes web servers publicly accessible. You host a website on a EC2 instance. Attaching an internet gateway allow users worldwide to access it. It is required for public subnets. A subnet becomes truly public only when its route table points internet gateway allows application to communicate with external services. For example, a server can download software updates called third-party APIs or connect to the payment gateways. It enables SSH RDP access from your laptop. Administrators can remotely connect to EC2 instances in public subnets for management and troubleshooting. It provides high availability automatically because it is being managed by the AWS itself. It is being used for internet facing load balancers. Services like application load balancers rely on internet gateway to receive requests from customers. So users via browser go to internet from the internet the traffic will come to the internet gateway, then application load balancer, then to the EC2 instance. It separates public and private architectures. It does not expose instances by itself. Even with an internet gateway attached, security groups and network ACLs still determine what traffic is allowed, which improves the security. No additional charge for the gateway itself. You pay only for data transfer, making it a cost-effective way to provide internet connectivity. Now let's see the NAT Gateway. It allows private resources to access the internet while preventing inbound internet connections. So consider a company mailroom. Okay, employees can send letters outside. So here we have EC2 instance in private subnet. So it's kind of mailroom. Employees can send letters outside, but strangers cannot walk directly into the office through the mailroom. So NAT gateway it acts like a secure mailroom. Internal systems can send requests outside, but outsiders can't directly enter. It supports container workloads in private subnets. Example from the ECS Fargate, if ECS services want to get pull the images from the ECR or from the Docker Hub, or they want to push the logs to the CloudWatch logs, okay, in that case, we will use the NAT gateway so that ECS task can go to the NAT gateway followed with the internet gateway, and then from the internet it will can pull and push. It allows private instances to send logs and metrics externally, provides a single public IP address for outbound traffic. If a partner company whitelisted your IP address, all private servers can access their service through the NAT gateway's elastic IP. Allows private EC2 instances to access the internet without being publicly accessible. It protects backend resources from direct internet access. In the another example, we can see we have an order service which is present in the private subnet and running inside the EC2. Through the NAT gateway, which is present in the public subnet, it can access the Stripe or any external API. It enables application to communicate with third-party services. It is fully managed and highly available within an availability zone. Now let's understand what is virtual private gateway. Let's consider a office building on the left side and AWS city on the right. So there is a secure tunnel them which is connecting the On-premises means office building and the VPC city. This tunnel can be a VPN tunnel, which is secure tunnel over the internet, or the direct connect, which is the fiber cable. So, a virtual private gateway, it is attached at the edge of the VPC and is the AWS endpoint of a secure VPN tunnel connecting your data center to AWS. So it provides an endpoint. Through that endpoint, AWS side resources can go to the corporate network or the on-premises router. The traffic can come to the endpoint, and from the endpoint it will go to the resources present in the VPC. It works with AWS Direct Connect for dedicated private connectivity. Financial financial institutions use Direct Connect plus Virtual Private Gateway for low latency, high bandwidth communication with AWS. It enables disaster recovery and backup solutions. Example: replicate on-premises data to AWS and quickly recover workloads during outages. It provides secure access without exposing resources to the internet. Example: internal databases and file servers remain accessible only through the corporate network. It allows multiple office locations to access AWS resources, like headquarters and branch office can securely reach application hosted in AWS. It integrates seamlessly with existing network infrastructures. Corporate routers, like custom gateways, establish VPN tunnels to the VGW with minimal changes to the existing setup. It securely connects your corporate data center to AWS. It enables hybrid cloud architectures. It keeps legacy applications on premises while running new microservices in AWS, like we can see in this diagram. We have legacy based application which is present in the corporate network. At the corporate network side, we have their router device which is connecting with the VPN tunnel over the internet securely, and it is connecting to the endpoint VGW gateway, and the resources present in corporate network can communicate with the new microservices which is present in the AWS cloud. It supports site to site VPN connectivity. It facilitates gradual cloud migration. Customer gateway resource in AWS, it's a logical representation of the device containing its public IP address and routing information. But the actual device is present at your corporate network, and this device is physical router. You can consider as the security checkpoint on your company campus, and this is how the traffic goes. Next is Transit Gateway. AWS Transit Gateway is a fully managed network transit hub that enables centralized connectivity between multiple VPCs, on-premises networks, VPN connections, direct connect connections using a hub and spoke architecture. Let's consider Transit Gateway as a airport hub which is connecting with the cities, multiple cities, like Broad VPC is one of the Mumbai city. Dev VPC is one of Delhi. Shared Services VPC is Bangalore. So it acts like a central airport hub and simplifying connectivity between many networks. Transit Gateway centralized connectivity between multiple VPCs. It simplifies network architecture. Instead of creating dozens of VPC peering connections, all VPCs connect to one transit gateway. It supports hybrid cloud environments. Example, on-premises data centers can communicate with multiple VPCs through a single VPN or direct connect attachment. It reduces operational complexity. Network administrators manage routes in one place rather than maintaining many individual connections. It enables shared services architecture. Security tools, DNS servers, or logging systems hosted in one VPC can be accessed by applications in other VPCs with the transit gateway. It scales easily as the organization grows. It supports multi-account environments. Different AWS accounts managed by separate teams can connect their VPCs using AWS Resource Access Manager. It provides better network segmentation. Example, production and development environments can be isolated using separate transit gateway route tables. It integrates with VPN and Direct Connect. It improves network management for enterprises. Large organizations with hundreds of VPCs avoid the complexity of maintaining a mesh of peering connections. And that's we can see in this diagram. Now let's see Egress-Only Internet Gateway. An Egress-Only Internet Gateway provides outbound internet access for IPv6 traffic while blocking inbound connections. The EC2 instance present in IPv6 private subnet can go to internet directly via egress-only internet gateway with the help of route table. Consider this as a one-way exit door. People can leave the building, but nobody can enter through it. It allows IPv6 instances to download software updates like, Ubuntu servers can fetch packages from the internet. It enables access to third-party APIs. Example, application servers can communicate with Stripe or Twilio. It protects servers from unsolicited inbound traffic. Hackers cannot directly initiate connections to the EC2 instance. It provides stateful behavior. Example, response traffic is allowed, but new inbound connect requests are blocked. Ideal, it is ideal for backend application servers. Example, web servers behind an ALB, internal microservices, container workloads. It eliminates the need for IPv6 NAT Gateway. IPv6 does not use NAT Gateway. Egress-only Internet Gateway provides outbound-only functionality instead. It allows container workloads to pull images like ECS task or Kubernetes worker nodes can pull container images from public registries while remaining inaccessible from outside. It improves security posture. Even though EC2 instances have globally routable IPv6 addresses, attackers cannot initiate connections directly to them. Now let's see the VPC Endpoint Gateway. The gateway endpoints create a private route to AWS services such as S3 and DynamoDB. It allows private access to AWS services without using the internet. You can consider a dedicated private courier lane. Instead of sending packages through public roads, you have a private road directly to the warehouse. Let's see some real world benefits of it. It accesses S3 without a NAT gateway. Application servers upload logs to S3. Without gateway endpoint, the traffic flow is first it will EC2 to NAT gateway, then internet, then S3. But with gateway endpoint, EC2 directly go to gateway endpoint which will go to the S3, which will save the NAT gateway cost. It keeps traffic private. Sensitive data never traverses the public internet. Example, financial reports, customer images, backup files will remain within AWS. It reduces net gateway charges. It enables private backups. Example, EC2 RDS snapshots. Lambda can store backups in S3 privately. It supports analytics workloads. EMR clusters and Spark jobs often read-write huge amount of data to S3. So gateway endpoints improves performance and reduce cost. Here, it accesses DynamoDB privately. Microservices can communicate with DynamoDB without internet access. No public IPs are required. Resources in private subnet can access S3 and DynamoDB without public IP address. It scales automatically. No capacity planning, patching, or maintenance is required. It is highly available by design. Since it is an AWS managed service, there is no need to deploy multiple endpoints across edges, availability zones. It is commonly used with Lambda and EC2. Also, there is no security groups are attached. Security is controlled through IAM policies, endpoints policies as the bucket policies, EC2 security groups. Let's see now the interface endpoint, which is behind the scene, is using AWS PrivateLink. You can consider a technology running behind. So an interface endpoint is a VPC endpoint that uses elastic network interfaces (ENIs) with private IP addresses to privately connect your VPC to support AWS services, AWS Marketplace services, or your own services without requiring an Internet Gateway, NAT Gateway, VPN, or direct connection. It provides private connectivity to AWS services or third-party services. AWS Private Link is the mechanism or technology which is being used by the interface endpoint. Consider a interface endpoint as a private intercom line between buildings. Through a private intercommunication line between buildings, there is no need to go through public phone networks, and different AWS services have separate interface endpoints. They are an EC2 instance communicate with the interface endpoint through their security groups. Let's see real world benefits. It accesses secret manager privately. Example, EC2 can go to the secret manager and access the secrets with the use of interface endpoint. No internet required. Session manager can access without public IPs. Session manager access without public IPs. Example, EC2 instances in private subnets. No SSH, no bastion host. Administrators connects via systems manager. Pull Docker images privately. Example, let's consider if we have a EKS node with the interface endpoint can go to the Amazon ECR. So there is no NAT gateway required. With the interface endpoint, we can access the KMS privately. Applications encrypt, decrypt data without traversing the internet. It communicates with SQS and SNS privately. Microservices can exchange messages without public connectivity. It reduces the net gateway traffic. Many enterprises use S3 gateway endpoint, ECR interface endpoint, secret managers interface endpoint to significantly lower net gateway cost. It connects to third-party SaaS services from your VPC with the private link enables it will go to the partner service VPC without exposing the traffic publicly. Serverless VPC applications. Lambda, let's consider a scenario. Lambda functions inside a VPC needs secrets manager. So Lambda can go to secret manager to access the secrets via interface endpoint. Benefits is Lambda function don't need internet access. Multi-account shared services. Security team. Let's consider a scenario where security team hosts a scanning service. Consumer account can go to the security service with from the interface endpoint. Consumer account will go to first interface endpoint, and interface endpoint is using the private link means it is not a separate resource but interface endpoint behind the scene it is using private link. So from private link to the provider account, and from the provider account to the network load balancer, and from the network load balancer to the security service. So we don't need to do VPC peering here. So this is a strong isolation. Financial institutions and healthcare. They require strict regulations prohibit internet traffic from private EC2 to the interface endpoint, and from the interface endpoint it can go to the AWS services, which meets compliance requirements and reduces attack surface. Now let's see the direct connect gateway, which is one of the important gateway. So what it does, it connects AWS Direct Connect links to multiple VPCs or regions via virtual private gateway or transit gateway. You can consider as assume a high-speed railway control station. A one railway can serve multiple cities through a central distribution hub. Let's see some real-world benefits of Direct Connect Gateway. Multiple VPCs using one Direct Connect circuit from the corporate data center to the Direct Connect and from the Direct Connect link to the Direct Connect gateway, which will connect to the VPCs via transit gateways and virtual private gateways. So there is no need for multiple dedicated circuits. It supports multi-region connectivity. Example, Mumbai region, Singapore region, Frankfurt region, all reachable through one direct connect connection. It enables hybrid cloud architectures. On-premises applications communicate privately with workloads in several AWS regions. Its centralized network design. Large enterprises often have headquarters, and headquarters to the Direct Connect and Direct Connect to the Direct Connect gateway, then transit gateways, and transit gateways is connected to the 100 plus VPCs. It reduces network complexity. Instead of connecting each VPC with the separate direct connect links, we connect with one direct connect gateway connecting with all VPCs. It works with transit gateway, useful for mergers and acquisitions. For example, different business units maintain separate AWS accounts and VPCs. Direct Connect Gateway provides centralized connectivity without redesigning each network. It supports disaster recovery architectures. Example, primary workloads run in Mumbai while disaster recovery workloads run in Singapore. Both regions remain reachable through one direct connect infrastructure. It eliminates regional limitations of virtual private gateways. Without direct connect gateway, the connection is on premises to direct connect through virtual private gateway to the single region VPC. With direct connect gateway, from on premises traffic can go to the direct connect, from direct connect to the direct connect gateway, and it can connect with Mumbai, Singapore, Frankfurt. One connection spans multiple regions. Final summary. You can consider Internet Gateway as public highway gate. You can consider NAT Gateway as the mail room, Virtual Private Gateway as the private bridge, Customer Gateway as the corporate security gate, Transit Gateway as the airport hub, Egress-Only Internet Gateway, one-way exit door, Gateway Endpoint, a private courier road, Interface Endpoint, a private intercommunication line, Direct Connect Gateway, a railway hub. That's all for this lecture. Thanks for watching. If you like this video, share this video, like, subscribe, and comment which topics you want to learn.